Hi guys, my name is Bailey Nouget and I'm going to be explaining the pH scale. The pH scale pretty much measures the concentration of hydrogen ions in a solution. It pretty much tells you how acidic or basic that solution is. It'll range from 0 to 14, with 0 being the most acidic and 14 being the most basic. In the middle, 7 is found in the center of the scale and is neutral. Pure water is an example of a neutral solution because it dissociates into equal amounts of hydrogen ions and hydroxide ions. Usually hydrogen ion concentration would be measured in grams per liter. However, this number can be really small, so pH kind of helps with that. For example, water produces 1 times 10 to the negative 7 hydrogen ions per liter. So when you calculate that out, you can see it's a pretty small number. So you would pretty much just want to count the number of decimal places on that number, which in this case for water would be 7, and that would be the pH. Hydrogen concentration and pH are inversely related, which means the more hydrogen ions in a solution, the lower its pH will be. And the more acidic it will be, and the less hydrogen ions in a solution, the higher its pH will be, and the more basic. This is just a visual representation of a neutral solution. It'll contain equal amounts of hydrogen and hydroxide ions. And then for acidic solutions, it'll contain more hydrogen ions than hydroxide. And for basic, it'll contain less hydrogen ions than hydroxide ions. Acids when acids dissociate in water, they produce a hydrogen ion and an anion. This causes an increase in the hydrogen concentration in the solution. That's the equation. So when an acid's placed in water, it'll dissociate into hydrogen and an anion. And since hydrogen is a proton, acids are also considered proton donors because they'll donate their hydrogen ions when they dissociate. Strong acids will dissociate to a greater extent than weaker ones. The stomach acid is an example of a strong acid. The hydrochloric acid, it'll have a pH of about 1, which is really low. When bases dissociate in a solution such as water, by contrast, they tend to take up hydrogen ions. Therefore, bases are considered proton acceptors. When bases dissociate, they decrease the total amount of hydrogen ions in the concentration, giving it a higher pH. And there's the equation. Weak bases dissociate to a lesser extent than stronger bases, and tend to leave more hydrogen ions in the solution. Blood is a good example of a weak base because it has a pH of about 7.35 to 8.45. On the other hand, strong bases will dissociate to a stronger extent than weak ones and leave less hydrogen ions in the solution. Household bleach is an example of a strong base with a pH of about 12.